Alright guys, this may be the last video that we'll be making for this class. Awesome job for those that have stuck through it. Again, I'm going to post this video with this homework explanation as well as the notes for this week. I have one assignment that I'm going to give you now, and it's due at the end of the week. I've been kind of drawing out and trying to pace it out, but at this point, I don't think anyone's going to turn around and say we haven't done enough. So here we go. The homework explanation from the 13th. Probability of success was 65%. Again, we're talking about Arctic terns surviving migration. So they know about 65% of the Arctic terns will survive. Therefore, we know that 35% will not. And there's 500 Arctic terns that we are keeping track of. So in order to do the normal distribution, we needed a mean and a standard deviation. Now, in the latest extension, I explained how to find the mean and the standard deviation given that we were given this information. So the mean was n times p, so 65% are expected to survive, so 65% of 500 is 325. So we're expecting 325 Arctic terns to survive. So if we had a normal curve, this 325 would be at the peak. Standard deviation, the square root of n times p times q, or the square root of 500 times 65% times 35%, so 10.7. So we're expecting 325 Arctic terns to survive, give or take about 11 Arctic terns. And so I plugged into the normal CDF, so my lower bound was 310, my upper bound was 340, because that's what the problem was asking us to find, the mean and the standard deviation. So I got 0.839. So the conclusion that I can make is that there's about an 84% chance that between 310 and 340 Arctic terns will survive the migration. So that was that problem. Nice job for those that got it. Now today what we're going to be talking about is the inverse normal distribution. Now the inverse normal distribution is, instead of finding the probability of something happening, they're going to give us the probability, they're going to give us the mean, they're going to give us the standard deviation, and then they're going to say whether the probability lies to the left of the value we're looking for, it lies to the right, or if our values are in the center. So what I have here is an example of a left, a right, and a center. When 50% of the data is recorded, the mean will be 0 and the standard deviation is 1. That means I'm using a standard normal curve. So I'm talking about the number of deviations from the mean. So if I plug this information into my calculator, what it's going to give me is the location of the deviation from the mean. It could be negative, it could be positive, but it gives us the deviation. If I actually gave you values, such as 50 and 10, when you plug it in, you're not getting the number of deviations from the mean, you're getting the value. So if you're expecting 50 and your value is going to be above 50, so let's say it's right here, then you're going to get something around 60 or 70 depending on how far from the mean it is. So those are the two answers you're going to be getting. Standard normal curve, you're going to get the number of deviations from the mean. If I give you values, you're actually going to get the statistical value. So this is an example where I am covering 50% of the data, and 50% of the data is to the left. If 50% of the data is above my deviation or above my location, it would look like this because it's to the right. And if I am in between two deviations, 50% of the data would fall in between. And this value and this value would be the deviations away from the mean, and they would be equal distance away. So if this deviation was, we'll say, -1, then this one would be +1. Now that's obviously not the answer because that would be 68% of the data, so we're probably looking at maybe -0.87 and +0.87. So the two questions I'm going to ask you is, first, what deviation do we fall if 30% of the data lies to the left? So 30% goes up to a certain deviation, and I want to know what deviation is that. The next question gives a little more of a purpose to these problems. What score must be earned, to be considered to be in the top 10% when the average score was an 85 with a deviation of 3? So I want to be in the top 10%, so that's going to be way over here and everything above. So let's try these two problems out, submit your work, and I I'm also going to be releasing how I'm going to be grading A's, B's, C's, D's, pass, NGC, all that stuff. So stay tuned.